Good evening, students. Welcome to one more session of your WOC. That's your Vani ma'am. I think the first NEET ABHYAS series 1 was really helpful for you all. Thank you so much for watching. So basically, as I said, here instead of solving the questions, first try to understand the concepts as well as tricks. So whenever you're trying to attempt an exam, whether it is your CBSE or your competitive exams, first important thing is using the trick within less time, within few seconds rather, using less time and using the trick, you need to solve the question. That is what is important. So time is a constraint, isn't it? With that time limit, within that you need to solve it and prove yourself. So the whole year preparation depends upon a consolidated sort of understanding. So today in this NEET ABHYAS series 2, I have picked up the next concept, that is inorganic chemistry. Very important. Those are the P block reactions. So 99% of the students, they feel difficulty in P block. So today I have almost again took for me almost 10 days to compile everything for you all students, because without you WOC is nothing, isn't it? Right. So in today's series, let us start off. Almost 55 to 60 reactions you're going to see in this video. How many? 55 to 60. It's a huge number, but in a very easy method. So I request you all to watch the whole video till the end, because if you don't watch it, you will miss a lot of tricks which are in between, right students? So what happens, I may give you a trick again after that example, maybe give you a trick again example. If you skip off the video initial stages only, you will not get to understand. So almost 50 to 20 tricks are there, beautiful tricks, with 55 to 60 reactions are covered in this video, right? Let us start off with the NEET ABHYAS series 2. Please stay connected, watch it till the end. Let's start the class, students. So this is the flow chart which I made for oxides of nitrogen. Everything will be covered in this. You can have, you can use it for your CBSE, you can use it for your NEET, you can use it for your JEE also, because basically P block chapter is that chapter where maximum questions are asked and the weightage of the chapter also is more. Correct? So I made a flow chart which is easily understandable. Just check. Here basically simple. The basic reaction is this. So here N2 plus O2. This is a basic reaction. Now what happens when you combine both together at 3000 degrees centigrade? The forward reaction gives you nitrous oxide, or nitrogen monoxide, and the backward reaction gives back you both N2 plus O2. Further, what did I further do? I have made reactions further continuing with nitrous oxide into these. Further reactions continued from nitrogen to further this, where both the Haber's process as well as Ostwald's process is here. Right, now just check. Here important thing is, nitrous oxide, when you're treating with 250 Kelvin at plus, you're treating with N2O4 or nothing but NO2 only, N2O4 is nothing but NO2, dimer of that. So you're going to get nitrogen trioxide. So just check, students. I'll be doing the mechanisms also in the next video. Inorganic reaction mechanisms will be done by me in the next video. Please watch the next video also. Next, further, when I take NO treated with oxygen, I'll be getting nitrogen dioxide. There are three possibilities. If you're further dealing or treating with water in the liquid form, you get nitric acid. If you're further treating at 620 degrees, the same gas, if you're treating with 620 degrees, it's going to dissociate into nitrous oxide and oxygen. NO plus O2, it becomes NO. Basically 2 2s of 4 are there. Here also 2 2s of 4 are there. Right. Next, further, if I take NO2 and if I am cooling it, means almost at minus 11 degrees centigrade, if I cool, I get at N2O4. If I heat it, I'll get back the NO2. So this is one way of understanding. Further, if I take nitrogen, if I am treating at 773 Kelvin, I'm including 3 hydrogen, means N2 plus H2. This is nothing but the Haber's process, isn't it? Here what will we use? We'll use iron oxide as a catalyst. I use potassium oxide and alumina as a promoter, right students? That is your Haber's process, which follows the Le-Chatelier's principle, and the temperature is the pressure is 200 atmospheres. So what happens here? It's going to form ammonia. Okay, now further ammonia, when you just add water to that, it's going to means when you're dissolving ammonia in water, you'll be getting ammonium cation and hydroxyl anion. Means this is a basic way of understanding. Okay, further I'm going to take the same ammonia, I'm introducing platinum as a catalyst and I'm adding oxygen. So this is nothing but, this whole thing is nothing but Ostwald's process. So Ostwald's process is used to prepare nitric acid. Haber's process is used to prepare ammonia. Done? Yes. So first, when you're trying to add oxygen, it's going to form nitrous oxide plus water. Further, I'm going to take same nitrous oxide and further allow it to undergo or add oxygen. It's going to form nitrogen dioxide. Further, I'm going to take the same nitrogen dioxide and add water and oxygen, you get nitric acid. So this basically is a summary of the whole oxides of nitrogen, which will be useful for all the reactions. Maximum all reactions are covered in this. Right. Now from here, let us see in the continuation of this. If I take further N2O3, what are the possibilities? Just check. I have written here. Just check. N2O3, I have three things. I can explain you in three different forms. That's for nitrogen trioxide, room temperature, what happens? When you add water, what happens? When you add sodium hydroxide, what happens? So I have the mechanisms for everything. I'll explain you in the next video. Right. So here N2O3, when you're treating at room temperature, it's going to break up into nitrous oxide and nitrogen dioxide, which is a reddish brown gas. Now, nitrogen dioxide further has just a, when you treat with sodium hydroxide as a base, when you treat it with water, when you treat it, this is your water, okay, oxygen plus water, then you'll be getting, when you treat with oxygen and water, you'll get nitric acid. When you're treating with cold water, when you're treating with hot water, when you treat with cold water, you'll be getting a combination of nitrous and nitric acid. When you treat with hot water, you'll get a combination of nitric acid and nitric monoxide, nitric oxide, nitric acid, nitric oxide, nitrous acid, nitric acid. So here like this, I compiled everything together in a particular flow chart, which will be very, very useful. Now, this is your flow chart for your oxides. Now, let us see the important reaction. That is, reaction, suppose if they give me how to solve the different varieties of reactions. So, different sort of reactions are there. Very easy technique I'll explain you. Let's come and see that. So let us see the reactions. If they're giving you different types, what are the products to write, how to write, let us see. Now let us take this page, right, proper. Now here, suppose they're giving you a reaction, something of this sort. Suppose decomposition reactions. Okay, so first let me discuss the decomposition reactions all together and then come back to you with different varieties with HNO3. So in decomposition reactions, when you're taking, first important thing, what should you remember? Let me start with the basic and the most important decomposition reaction, that is with the heat. Okay, so I'm going to decompose in the presence of with heat. Okay, done. Let us check. Now here I'm going to take ammonium nitrate. Okay, NH4NO3. Now, ma'am, ammonium nitrate, what is the precursor? From where it is prepared? Just check. You can prepare ammonium nitrate from, just check, potassium nitrate plus ammonium sulfate. Potassium nitrate plus ammonium sulfate. Now what happens? Just stick here, ammonium nitrate plus K2SO4. So it comes out. Further, you can also prepare ammonium nitrate from sodium nitrate NO3 plus you take one more ammonium salt, ammonium chloride. See here, ammonium nitrate, NaCl, ammonium nitrate is here. Done. Now first important thing, whenever you have ammonium nitrate, try to remove maximum water molecules. Remove maximum water molecules. This is the simplest logic if you have to see. My maximum. How many water molecules are there? Means higher. This one is there, hydrogen 4. So how many water molecules I can remove? I can remove 2 H2O because here 2 2s are 4. Correct? No? 2 2s are 4. So 2 2s are 4 hydrogens have come out. So how many are left? No, this nitrogen is left, this nitrogen is left, one oxygen is left. So nothing but N2O gas. Simple. That's nothing but your laughing gas. Laughing gas is released. So the trick here is remove maximum water molecules when you see ammonium nitrate. Nothing to get confused. So ammonium nitrate you see means you just remove. Okay, this is one. Suppose if I have or if they give me one more compound, let me check whether I can do it or not. Yes students, let me see whether the lens is clear. Okay, it's clear. Right, now just check. Suppose they give me one more reaction, that is with hydroxylamine. So here in the exam, you're seeing decomposition of hydroxylamine, you're just checking. So here what happens, suppose hydroxylamine is NH2OH. Now you're adding nitrous acid to this. What is this nitrous acid? The trick is it easily gets oxidized. Easily means when oxygen is present, no, immediately it adds on oxygen to that. So this oxygen gets added, easily gets oxidized as said. What will happen? HNO2 plus 1. This becomes HNO3. Done. The leftover is what? The leftover is what? This NH2 and this hydrogen. This comes to NH3. Now, this whole thing combines together. Just check. This whole thing combines together. And what will happen? It forms ammonium nitrate. Now check, as we have said, whenever you're heating ammonium nitrate, only two products we get. What is that product? One is nitrous oxide, laughing gas, and the other one is water molecule. Two water molecules you'll get because 4 are there. Simple. If I know this, I'll easily do this. After that, both will combine. They'll give me, on heating, they give me nitrous oxide and water. That's fine, students. Easy. I'm trying to make it easier. Now, we will see one more hydroxylamine. That's nothing but hydroxylamine hydrochloride. This is also similar reaction. Let's check. Right. So here, suppose I have NH2OH dot HCl. What is this name? Hydroxylamine hydrogen chloride. Suppose here I am going to add NaNO2, same thing like HNO2. It is easily oxidizable. So this oxygen is picked up by NO2. NaNO2. What do I get? When this oxygen combines, this one combines with this also combines with this also combines with this. What do I get? NH3 plus 1, 2 plus 1, 3, 3 plus 1, 4. It has become NH4Cl plus NaNO3. Now, check here, check here, sodium chloride comes out and ammonium nitrate is out. So same story, when ammonium nitrate is there, when you further heat it, it will break up into two different compounds. That's nothing but N2O and water. So what should you do? Whenever you see ammonium nitrate, remove maximum water molecule. Maximum water molecule. Simple. Correct? No? Yes, students, easy, right? So simple decomposition reactions, very easy to solve. Okay, one more we will see now. Very interesting. Suppose in the exam paper, okay, I have the other side. In the exam paper, if they give you any type of salts, like ammonium salts, let them give you any type. Now we saw ammonium nitrate, no? Suppose if they give you salts of ammonia. So let me take any salt of ammonia. Any salt of ammonia, let them give. So ammonium salts, like for example, let them give me a salt of ammonium nitrite. Let them give me a salt of ammonium nitrate. No problem. Let them give me a salt of a complicated one, like Cr2O7. Cr2O7 minus 2 potassium. Oh, sorry, dichromate. Or if I see dichromate, I remember manganate. Correct? No, like this, right? So simple thing. Just see, students. Here, whenever you're taking, just see for manganate, for dichromate, and for your nitrite. So manganate, dichromate and nitrite. So only for this, no, just check, only for this you will be getting only when it is nitrate. Only for nitrate, the product which you get is NO2 nitrous oxide plus water. For remaining all, which one? For this one, for this one, and for this one, all the three, the products are nitrogen gas and water. Simple. Let us see the reaction of this and understand. Suppose if I am taking ammonium nitrate, anything we will take. So I said, let me take one example of ammonium nitrate. I said it's going to dissociate. What is it going to dissociate into? It's going to dissociate into, as I said, just now we saw, no, nitrate always dissociates into N2O plus water on heating. This is on heating. Now let us take the next one. Ammonium chromate. Ammonium chromate is Cr2O7 that is taken twice. When you're heating this, simple. First thing, what should you get? Ammonium chromate. What should you get? Nitrogen. Take out After this, water. Okay, how many waters are there? 4 twos are 8 are there. Hydrogens are 4 twos are 8. So I'll make 4 water molecules. Okay, now check. 4 water molecules have come out. 2 nitrogens have come out. What am I left with? What am I left with? Here, oxygens, how many are over? Already 4 are over. 4 oxygens are over. How many are left now? Cr2O3. Now check. Chromium is true. 2. Oxygen is 3 plus 4, 7. Nitrogen is 2 and hydrogen is 4 twos are 8. Perfect. Perfect, students. Everything will be like this only. Now let us check. Let me take out my page and use the next one for you all. Right. Suppose one more decomposition reactions. Careful. Just see if they are giving you further. Let me check further decomposition reactions if I can do. If they give me, let me take my scale and I think, okay, my scale is missing. No problem. Let me just take this reaction and check. Further, ammonium nitrate we saw, ammonium chromate we saw, ammonium phosphate, sulfate, right? Right. Now, if they give me a particular thing like, ammonium, sulfate, phosphate, carbonate, in your halo, you see, cations and anions, correct? So, in the anion part, if I have to tell you the radicals when you check, right? So here if I see any ammonium salt, so any ammonium salt if I take, suppose if I am taking in the, when you check your independent radicals are there, independent radicals are sulfate, phosphate. So if they combine with independent radicals, what are the independent radicals? Means just like phosphate. If I take your phosphate is an independent radical. If I take one more sulfate, SO4 minus 2. So what do they give? They compulsorily form or release ammonia. The ammonia gas is compulsory along with the acid plus ammonia gas. Okay, let us check. Suppose if I take the same ammonium salt and if I am allowing it to combine with carbonate, like ammonium carbonate, what does it give? It again gives me ammonia plus acid. Suppose if I take halogens, like if I take chlorine, it also combines, further I'll take, it will also combine to form same product. If I take bromine, same story, it also combines to give same product. Isn't it interesting, students? All halogens, fluorine, chlorine, bromine, iodine. So let us see these reactions, how they are going about. So iodine also the same concept. Let's see the reaction. How I said ammonia plus independent radicals plus the carbonate anion and the halogens X minus. So they're going to give me the same ammonia plus acid. Let us take, suppose independent radical. So let us write reaction of ammonia with independent radical. Okay, independent radical means what did we say? Just now we said sulfates, phosphates, correct? Now I am going to take ammonium sulfate. In ammonium sulfate, sulfate valency is 2, so I am writing so 4. I am going to take ammonium phosphate, correct? Charge valency. If I am heating, what do I get? They said it's going to give an acid plus which gas? It's going to be acid plus your ammonia gas. So take out what is the acid present in this? What is the acid present in this? Sulfuric acid. What is the acid present in this? Phosphoric acid. Correct. Now, along with this, what should come out? Ammonia gas should come out. Ammonia gas. Perfect. Correct. Now, suppose if you take ammonium carbonate. Okay. Ammonium carbonate. Ammonia taken twice. Carbonate valency minus 2. Just to mention the charges. Okay. Sulfate valency. So, this is 3. This is 3. Okay. Next comes carbonate valency is 2. Now when you heat it, what is the acid formed? The acid which is formed is carbonic acid. So we very well know carbonic acid is not stable, correct? Okay, let us write ammonia gas. Carbonic acid is not stable. It's going to dissociate into 2, that is H2O and carbon dioxide. Correct? So it's not stable, no? That's why it's going to convert. Suppose if I take ammonium chloride, when you're heating, what will happen? It's going to give ammonia gas plus HCl. Suppose if you take ammonium bromide, what do you get on heating? Ammonia gas plus HBr. Correct, no? Yes, students, simple reactions. Only thing you need to remember this one. Yes, students, simple. Now, let us see some more reactions. Interested? Yes? Yes. So, some more reactions we will see. Further, if I take this next reaction, we'll be taking again decomposition reactions of metal nitrates. So, let us see. So, decomposition reactions of metal nitrates. So done. So metal nitrates, basically when I have to take, what is the thing? Always remember, whenever metal nitrates, if they are heated, suppose if they are heated, what do you get? You get metal oxide plus NO2 gas plus oxygen. Remember this. Right, here metal nitrates can be anything, just like your group 1, group 2 transition metal elements, not a problem. Suppose if we take, basically let me start with the basic thing, that is lithium nitrate. So here lithium nitrate valency is +1 -1. You're heating it. So this is your metal nitrate. Metal oxide, what is a metal oxide? It is Li2O, because oxygen valency is -2, lithium is +1 over. What will I get? I'll be getting NO2 gas plus oxygen gas. This is fine. Correct now? Now, what are the metals which are in diagonal relationship with lithium? Tell me. Magnesium nitrate, calcium nitrate, strontium nitrate, barium, lead, copper, zinc, isn't it, students? Correct, no? Yes. So the whatever metals or the metal nitrates, those also will give the same reaction. That also we will see. Suppose if you have lead nitrate, PbNO3 is here. On heating, what should it give? Same. Lead oxide plus NO2 plus oxygen. Okay, just I'll not write this one every time. You only tell me now. Zinc nitrate, same thing, metal nitrate on heating gives me zinc oxide plus same. If I take silver nitrate, silver nitrate, +1 -1. On heating, I get silver. This is remember, this is least reactive metal, so directly silver precipitates out, and NO2 plus oxygen. Okay, done. We'll take more and more reactions. Now I told you, isn't it? So the other metal nitrates which are in diagonal relationship with lithium, what is that? That is nothing but magnesium nitrate, nothing but calcium nitrate, nothing but strontium. Basically all what do you say? Calcium valency. Okay. Right, so all strontium, barium, copper, like that, or zinc, I already wrote. All these also are going to give metal oxide plus nitrogen dioxide gas plus oxygen gas. So this is a brown color gas. So nothing, simple. If I take magnesium nitrate, okay, magnesium nitrate. So magnesium nitrate, if I heat, what happens? What did I say just now? Magnesium nitrate is nothing but when decomposes to form metal oxide, correct, no? Metal oxide and nitrogen dioxide, as well as, what did I say? It's oxygen, correct? So here, what should you remember? If you remember one important thing, it's easy for you to answer. So magnesium nitrate, let us write magnesium nitrate, valency 2, on heating forms magnesium oxide plus NO2 plus oxygen. Simple, students. See how many reactions we have studied today. Isn't it simpler for you all? Simpler for you all? Yes. So just check. Now let us see if you're heating azides. So normally this is quite common reaction, azides, where we prepare the pure form of nitrogen. Correct. Now let us see preparation of pure nitrogen from azides, from decomposition of azides. Azides, okay, what is the formula? Azide is nothing but, suppose barium azide, barium, Ba, azide means nitrogen. Barium valency 2, azide valency 1. Sodium azide, NaN3, sodium valency 1, azide valency 1. When you're heating these two, first important thing, nitrogen gas comes out. because pure form of nitrogen you're preparing. Now, plus how many nitrogens are there? 3. How many nitrogens are there? 3 2s are 6. 3 2s are 6. Here how many? 3. So that means one more is there. I have to write. So that's nothing but sodium is here, barium is here. Now 3 2s are 6. So if I write 2 here, this also will become 2. It's balanced. So this is the reaction or the decomposition of azides using a preparation of nitrogen, pure nitrogen gas. That's okay. Now let us see the important thing, reaction of nitric acid. Very, very, very important. So let us see the action of HNO3. So basically HNO3 nitric acid, we have 3 conditions which we have to learn. That is, how is the reaction with very dilute nitric acid, very dilute HNO3? How is the reaction with dilute HNO3? How is the reaction with concentrated HNO3? This is the concept. Correct? Right. Now, in this also, we are going to take both. We are going to take both metals combination for all the 3, and we are going to take also non-metals. Done. Metals, again, you have 3 varieties, that is least reactive metals, next would be less reactive metals, next would be high or more reactive metals, high reactive metals or more reactive metals. Isn't it, students? Done. So here in this case we will be taking phosphorus, sulfur, iron, carbon, like that. So shall we see the reactions? Very interesting. Yes. So please keep noting it and just check. Suppose you have, let us take the first one. I am taking the least reactive metal. Now what are the least reactive metals? Basically, if I have to see, this is silver, gold, platinum, which are below the hydrogen in the reactivity series. Less reactive metals are copper, like that is also below. More reactive metals, if I have to say high or more reactive metals, it includes zinc, sodium, iron. Right, students? So now let us see. Let me turn the page and check what are the reactions of the least reactive metals. Now let us see the trick, what we have to remember. Okay. Now if you have to see, as I said, there are 3 conditions, correct? Now let us write. Suppose if you have a least reactive metal, done. You are trying to combine. So what are the least reactive metal? As I said, it is silver, gold, platinum, which are below the hydrogen reactivity series. Suppose if you are combining this with dilute HNO3, correct? If you are combining this with concentrated HNO3, suppose if you are checking both the conditions, just check here. Only in high reactivity metals you just see the very dilute condition. So dilute HNO3 means it's nothing but 6 to 10%. 6 to 10% is very dilute. Dilute means 20%. Concentrated means, you know, like almost like 60 to 70% concentrated. Done. Suppose if you are taking dilute HNO3, always remember the products are metal nitrates plus NO plus water. So in dilute it is always NO. If you take concentrated HNO3, it's again metal nitrate plus NO2 plus water. So in concentrated it is NO2, in dilute it is NO. Right. Suppose if I take less reactive metals. So less reactive metals are what? Less reactive metals are, if I take copper in this series. Okay, right. So here you can also take simply just if you further want to write lead also, copper, lead, you can take. Suppose if I am adding dilute HNO3, what is the concentration? It's 20% concentrated. Suppose here you are adding concentrated HNO3, right, students? Done. If you are taking dilute HNO3, remember the product formed is metal nitrate as usual. In all the cases, metal nitrate is compulsory, so common. So metal nitrate, same thing. In dilute, you will be getting exactly NO plus water. Here concentrated also same, NO2 plus water. Suppose if I take more reactive metals, more reactive metals are there. What are they? They are nothing but zinc, sodium, iron. Compared to them, they are above the hydrogen in the reactivity series. There are three conditions. Very dilute HNO3. Very dilute means how much? It's almost 6 to 10% concentration of HNO3. Suppose if you have dilute, which is 20% HNO3. Further, you have concentrated HNO3. So what happens? Very dilute, if it is there, the product formed, you need to remember, it is metal nitrate plus ammonium nitrate plus water. Suppose if I am taking 6 to 20% HNO3 dilute. Alright, yes, dilute HNO3, the product as usual is metal nitrate. But here, remember, for highly reactive, in dilute, you get laughing gas, nitrous oxide plus water. Suppose if I am taking concentrated conditions, the product is metal nitrate plus nitrogen dioxide plus water. So, in concentrated, NO2, NO2, NO2. Remember, right? So, this and this is similar, only differences in this and ammonium nitrate in very dilute conditions. This is okay, students? Yes, easy. Now, let us take the reaction and start writing. Suppose if I am taking the least reactive metal. So what did I say? Least reactive metal is nothing but silver, gold, like that. Well, let us see. Suppose if I am taking silver, I am going to add dilute HNO3. So almost how much dilute means? Here in this case I am using almost dilute 50%. Means less than that. So I'll be getting, what did I say? Metal nitrate. That is nothing but silver nitrate plus, if it is dilute, what should you remember? What did I say? In dilute, it is NO. Correct, no? Plus water. So, if I have to balance this, this is 3, this also is 3, this is 4. If I have to write for this 2. This is your dilute. Suppose if you are using concentrated HNO3, you are using HNO3 which is concentrated. This is concentrated. What will I get? Same metal nitrate only. But the difference is, I'll be getting NO2 plus water. If I have to balance 2 here, NO3, that's fine. So, dilute, concentrated. Now, let us see the reactions of, what do you say? Middle reactivity or less reactivity. It is not middle reactivity, less reactivity. So, let us write action of HNO3 with which one? With less reactive metals. Less reactive metals. So, less reactive metals means what? What did we say? Just now, you can either use copper. Copper is one less. Lead. There below. Correct, no? Yes, in the reactivity series. Okay. I'll be doing the mechanism as I said in the next video. Remember. Suppose if I take copper, I am using dilute HNO3 to this. I am using the same copper, I am introducing, this is dilute HNO3, this is concentrated HNO3, both. What did I say? In both the cases, it is copper nitrate only, metal nitrate. Copper nitrate, copper nitrate. But in dilute, I'll be getting nitrous oxide. In concentrated, I'll be getting nitrogen dioxide. Water, water. Simple, students? Yes. Now we will see the action with or action of HNO3 with more concentrated, more reactive metals. So action of HNO3 with which one? With which one? With more reactive metals. More reactive metals. So what are the more reactive metals we have? We have zinc, sodium, iron. So what did we say? We said we can use it in 3 conditions. Let us check. Suppose if I am taking this in under 3 conditions, that is, if I take very dilute nitric acid. Very dilute nitric acid means how much? It's almost 6 to 10% diluted. Means almost 90:10. So if I take dilute HNO3, here how much? I am going to use 20% nitric acid. Further, I am going to use concentrated HNO3 more than 50%. Alright? Almost 70 if I have to tell you. What will happen in all the cases? Zinc nitrate is Compulsory. Zinc nitrate is very, like, it's compulsory formed. What should you remember? More reactive metals with very dilute HNO3, compulsory ammonia is released in very dilute. If you take dilute, N2O is released. If you take concentrated, NO2 is released. Remember. Let us write the reactions now, right? So I'm going to take very dilute. I'm taking this first condition, zinc plus HNO3, that is very dilute, very dilute. What product will I get? I'm compulsory going to get zinc nitrate, that's compulsory. Along with that, ammonia is said. Yes, here ammonia comes out in the form of ammonium nitrate, which further dissociates into nitrous oxide and water. That's fine. Along with this, water. Let us draw one line. Suppose if I'm taking dilute HNO3, zinc plus HNO3, now this is dilute. This is how much? This is almost 20%. Here this is 6 to 7%. This is 6 to 10%. This is 20%. Same thing, you will be getting zinc nitrate, perfect. But what did I say? I'll be getting N2O. N2O plus water. Further, if I have to take with concentrated HNO3, what did I say? This is almost 70%. Okay, 70% is more, no? Right? So 70% zinc plus HNO3. Same thing again. Now I said it is zinc or metal nitrate. Metal nitrate is common. So metal nitrate, now here this is 70%. So first write zinc nitrate, done. What is it going to give? It's going to give nitrogen dioxide plus water. So this is the only difference in all the three. That's fine, students. Now let us see the reaction of HNO3 with non-metals. That's fine. So let us write reaction of nitric acid with which one? With non-metals. With non-metals. So what are the different non-metals? Let us take it there in NCERT. P4, I2, S8, carbon. So when you are trying to mix, we are trying to use concentrated HNO3 here. So all are going to form acid plus NO2, because it is concentrated means compulsory NO2 is formed, water. Now let us write the reactions. Phosphorus, what is that? P4 plus HNO3, concentrated. What will I get? I said acid. What is acid? Phosphoric acid plus NO2 plus water. Let us take iodine. Iodine, I2 plus HNO3. I'm not writing the balancing, I'm just showing it to you. What acid you get? Hydroiodic acid plus same compounds. Now let me take further S8. Sulfur 8, if I take, it's going to give me sulfuric acid, same byproducts. If I take carbon, it's going to form carbonic acid plus NO2 plus water. Now carbonic acid is not stable, no? It's going to further break into water and carbon dioxide. Yes, students, isn't it not interesting? Isn't it easy? Yes. So here, basically, remember the reactions are very easy. Okay. Now, the only thing is you need to remember what is the trick. Now, let us see three more reactions, very important reactions with potassium nitrate or sodium nitrate. Okay. Now, if I take potassium nitrate, there are two things. Suppose if I take potassium nitrate and add concentrated sulfuric acid to this is one concept. If I am taking same potassium nitrate and adding sulfuric acid and along with this ferrous sulfate also, just check. With concentrated concentrated sulfuric acid, it's going to form, or even you can take sodium NaNO3 also. Both the things we will write. Suppose I am going in this direction, right? Here this is going to break up as, just see, sulfuric acid I can write it as H plus and HSO4 minus, correct? Yes. Now this is plus, this is minus. Check what are the products are KH, plus and minus, SO4 plus HNO3. With NaNO3 let us write Let us write NaNO3, Na plus, NO3 minus. Na will combine with HSO4 forming sodium bisulfate plus HNO3. Simple, isn't it? Yes, students. Simplest reaction, done. Suppose if you are having sulfuric acid and ferrous sulfate. So this mechanism also I'm going to show you in the next video. Just see what will form. It's going to form potassium sulfate. Now ferrous will get converted to ferric. This is important. Ferrous to ic. Lower oxidation state, higher oxidation state. Plus water plus NO. I'm not balancing anything, just showed you the skeletal reaction. So this is how almost 55 reactions we have covered. More than that we have covered in this video. Yes, students, hope the video is clear. So I have completed reactions with decomposition reactions. I have completed the flow chart for oxides. I have completed the decomposition of azides, reaction with nitric acid, correct, no? Yes. So thank you so much, students, for watching. I'll come up next with the inorganic reaction mechanisms. Thank you so much. This is your Vani ma'am signing off. God bless you all. Meet you in the next series. Please watch it. If you all watch it and make it successful, keep sharing it. It will give me energy to do the next video. So this is your Vani ma'am signing off. Take care. Bye-bye.